Hello! In today's lesson we're looking at Chapter 10, Section 5, Segment Lengths in Circles. Our objectives are to be able to solve for segments of chords, tangents, and secants. We start with some theorem. Theorem 10.15. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. That means that here we have chord BA and CD. We can say that EA times EB is equal to EC times ED. Theorem 10.16. If two secant segments share the same endpoint outside a circle, then the product of the length of one secant segment and the length of its external segment equals the product of the length of the other secant segment and the length of its external segment. So in this case over here, we've got two secants. We've got EB and ED, and their lengths are basically EA times the whole length EB is equal to EC times the whole length of ED. Theorem 10.17. If a secant segment and a tangent segment share an endpoint outside a circle, then the product of the length of the secant segment and the length of its external segment equals the square of the length of the tangent segment. So the tangent segment over here is EA, so you're going to take the square of that, and that is equal to EC times the length ED. Example 1, finding segment length. Chords line segment JN and line segment KM intersect inside the circle. Find the value of X. I can see JN and KM. Neither one of these chords are diameter, so I can't say that one chord is cut in half and therefore bisects each other. So I need to find the value of X, and I'm going to use Theorem 10.15, which says that if I have two chords intersecting inside a circle, then the product LJ times LN is equal to LK times LM. So I have 10 times X is equal to LK, which is 8, times LM, which is 5. 8 times 5 is 40. Isolate X by dividing both sides by 10. X is equal to 4. Example 2 is another one for finding segment lengths. This time I have two secants intersect at the same point, and for this I need to find the value of X. So I'm going to be using Theorem 10.16 to solve for the value of X. In 10.16, I know that the length of AB times the entire secant, which is AC, is equal to the external part of the secant AD times the entire length AE. So AB we know is 12. The entire length of AC is 12 plus X, or X plus 12, and then AD is 15, and AE is 9 plus 15, which 9 plus 15 is 24. Solve for X. We start off by distributing the 12 with X and positive 12. 12 times X is 12. 12 times 12 is 144. 15 times 24 is 360. Subtract 144 on both sides, and you get that 12X is equal to 216. Divide both sides by 12, and 216 divided by 12 gives us X equals 18. Example 3, estimating the radius of a circle. You are standing at a point Q about 9 feet from a large circular tent. The distance from you to a point of tangency on the tent is about 24 feet. Estimate the radius of the tent. In this circular tent and a point of tangency, we have a tangent and we have a secant. So I'm going to use Theorem 10.17 to solve for our radius. According to 10.17, our tangent square, QP square, is equal to the external part of our secant, which is QS, times the entire length of our secant, which is QT. We know that QP is 24, so that's going to be 24 square, is approximately equal to 9, which is my external length of my secant, so QS, times the entire length over here, so it'll be 9 plus R plus R. We know R plus R is going to be 2R, so it's 2R plus 9. 24 square is 576. Distribute the 9 to get rid of the parentheses. 9 times 2R is 18R. 9 times 9 is 81. Subtract 81 on both sides. 576 minus 81 is 495. It's approximately equal to 18R. Divide both sides by 18, and 495 divided by 18 gives us approximately 27.5. So our radius for the tent is about 27.5 feet. Example 4, again, another one finding segment lengths. This time I have a tangent and I have a secant meeting at the same point outside the circle. According to Theorem 10.17, we're going to take the square of our tangent, which is VW, and that is equal to the external length of our secant, which is WY, times the entire length of our secant, which is WZ. We know that VW is 10, so it's going to be 10 squared, and we know that WY is X, and the entire length of WZ is X plus 12. When we multiply this out, you're going to end up with 10 squared, which is 100, is equal to X times X, which is X squared, plus 12X. This is a quadratic function. In order to solve this, you need to write it in standard form, which means subtract 100 on both sides. What you end up with is X squared plus 12X minus 100 is equal to 0. From here, use the quadratic formula to solve for X. Remember, the quadratic formula is negative B plus or minus the square root of b squared minus 4ac all divided by 2a. So in this case, my b is 12, so it's going to be negative 12 plus or minus 12 squared minus 4 times 1 times negative 100, all divided by 2. Going to do the math over here. So this is negative 12 plus or minus 12 squared is 144. Negative 4 times 1 is negative 4. Negative 4 times negative 100 is positive 400, all divided by 2. This becomes negative 12 plus or minus the square root of 544 divided by 2. Simplify the square root of 544, so the smallest prime number I can divide 544 by is 2. That gives me 272. Divide that again by 2. That gives me 136. Divide again by 2. That gives me 68. 2 gives me 34. 2 gives me 17. And the next number I can divide 17 by is 17. Every time I have a pair, I'm going to take one of those guys out, get rid of the other, take one of those guys out, get rid of the other. Whoever's left goes back in the house. So I'm going to put the work over here. This simplifies down to negative 12 plus or minus 4 times the square root of 34 divided by 2. I can simplify both negative 12 and the plus or minus 34. Essentially, I can rewrite this as negative 12 divided by 2 plus or minus 4 square root of 34 divided by 2. Negative 12 divided by 2 gives me negative 6 plus or minus 4 square root of 34 divided by 2. I can simplify the 4 and 2. 4 divided by 2 is 2. So that's 2 square root of 34. And so X is the positive value of negative 6 plus 2 square root of 34, because what we're looking for, which is X, is a length, and you can never have a negative length. You can plug this into your calculator. So negative 6 plus 2 square root of 34 is just going to be 5.66. Alternatively, you could have just taken this value over here with negative 12 plus or minus square root of 544 divided by 2, plug the positive function into your calculator, and given the decimal answer as your solution. Checkpoint problem number 1, 2, and 3 are yours. In checkpoint problem number 1, chords of line segment MP and line segment NQ intersect inside the circle. Find the value of X. 2. Find the value of X when you have two secants meeting at the same point. And 3. Find the value of X when you have a secant and a tangent meeting at the same point. Alright, that's it from me. I'll see you all soon.